It's a pleasure to welcome you all. Probably this is not our standard configuration. We normally are in the auditorium, which would be a bit more suited with a number of people that will deliver and hand over the diplomas to the candidates. But the room was not available today, so we have to do it here. And I think we can do it here well, and equally well, or even better. This is the diploma ceremony for the award ceremony for the Kiyoung Automotive Systems Design. Family and friends are here, and also we are live stream connected to all over the world, and that is also a reason for us to keep close to the microphone and probably a little bit fixed to one position to make sure we're always in the camera. Today, 13 Kiyoungs will receive their diploma as technological designer, and that's a number where we are certainly very, very proud about. Eindhoven, TU Eindhoven has all in all 11 of these designer programs, and Twente and Delft are much lower with 3 and 5 programs. So it's really at the Technical University of Eindhoven, this is a very popular activity. Kiyoung programs are really a very versatile and useful collaboration between industry and academia. And as you may know, of course, we are always very proud about being part of TUE, but probably you also know that the Technical University of Eindhoven is first in publications jointly with industry all over the world. This is something where we are extremely proud about. It shows how well we are aligned and connected with industry. And this Kiyoung program, Automotive Systems Design, and also today there will also be 4 students who receive their diploma, say in Mechatronic Systems Design. That is sort of an example of this collaboration. The task of a young engineer is, of course, knowledge valorization. How to make value out of knowledge. PhD students, research-driven, is probably more the focus on the research itself and slightly less on valorization. In a Kiyoung, we sort of focus more in collaboration with industry on the valorization. And that means that the Kiyoungs are also trained as such, trained also not only in their specific activities, automotive systems design, but also on what are aspects in system design not as a single person, but also as in part of a team. And you together formed the team for the past 2 years. As of today, you may, at the end of the day, you may use the degree Professional Doctorate in Engineering, or Kiyoung. It gives you an important advantage in industry. And when you submit an application, we think you will definitely have profit of this Kiyoung degree. Of course, this is not a Kiyoung you don't see in every country. Say in Europe you find few countries where you have similar degrees, but definitely by now more and more Kiyoungs find their way even outside Netherlands. There are in Germany some companies that hire and are extremely happy with your education. So if you don't find a job, let us know and we can probably even give you some guidance in that. We wish, of course, all of you lots of success in your future career. And I will be back on that at the very end. We thank, of course, the high-tech industry, the industrial people, and most of the students will get their degree and will be addressed by one of the daily supervisors, which is I'm very happy to have them here. We thank them, of course, extensively for all the work you have done in the past year. The protocol, a few words on that. As said, the supervisor from industry and in some cases from university will give a short introduction on the project to the graduation student. The Kiyoung is supposed to stand here, just next to me. The photographer will say if it's exactly the right position. That's for the photo. And as the moment comes when you hand over the degree, please make a step forward and give the diploma then to the candidate. I also, when that is done, I will also give the candidate a slash. This is a slash. You will all recognize this as part of the TUE symbol. It's a very useful tool. You should take me very serious in this. It's a very useful tool. First, it is an important sign of you're an alumnus of the Technical University of Eindhoven. That's the main thing. You must be proud about this. There are very few people in this room that have a slash. So that also makes you unique, this way, be proud about it. I don't want to find at the end of the day a couple of these slashes left over. That's one thing. If you don't know what to do with it, you can certainly use it as a sort of box, at least that I've been told. You can open it, put your diploma in, and then bring it home. So it's also very useful in that sense. But normally, put it on your desk and think about it even years after today. At the very end, I will be back here and say a few more words. We have to make an arrangement for making some pictures afterwards, and it probably will mean that we will ask you to leave the room first, so that candidates and the group here can stay and make some of the photos. Okay. Okay. The preference is the other way around, so we leave the room. This is changing already 3 times in the last 15 minutes, so apologies for that. And probably it will change again, but the idea is, so we will leave the room earlier, you guys, and I ask you, family, friends, stay here, discuss things, whatever you wanted to ask your neighbor first, and wait until we give a sign to come out. Okay, let's get started. The first candidate for today is Saffora, and she will be addressed by Dino Sepak from TAF. Please.
So first of all, I wish a good afternoon to all of you. Well, it's my special honor and a special moment for me as well, because I was on basically the other side of this room a couple of years ago, and I have to say now I'm a bit more excited than I was back then. I don't know if that's a normal procedure, but either way, knowing the both sides of the story, I first of all wish to congratulate all of the great people here in the first rows that are minutes away from joining the PDN club. And I also want to, first of all, thank and then also congratulate basically everybody else who were there all along somewhere in the background. So, thank you. Now, as probably you can read here, Saffora did her project at DAF Trucks. DAF Trucks, well, makes trucks. And trucks are everywhere around us, basically. So you can also find them in the city center. And there, the drivers, despite their best intention, needs to navigate the pedestrians, the cyclists, and all other absent-minded traffic participants. Now, one way to avoid accidents in such situation is for me to warn you, please be careful, because the driver cannot always see you. But also, on the other hand, what we can also do is try to make the driver more aware of the chaos happening around him. And that's exactly what Saffora was busy with in the past 10 months. So, Saffora actually brought a great new fresh spirit to our team, to our environment. And as she promised during the interview, she was very quick to adapt to the new oncoming insights, both coming from her study, but also from the organization and all the stakeholders with decided opinions. And combining all of those, actually, Saffora did a great job. In the end, what we were able to witness was not only a study, but also a live demonstration on the truck. So that was the real proof of the well-done work. And then, speaking of the study, you probably have heard of some historically traditional wise thoughts coming from the area of Greece. Well, apparently that was still the case, so the trend continues, and we were, in the meanwhile, so in the past weeks, already able to use the insights and benefit from them that Saffora was able to provide us. So on behalf of DAF and on my own behalf, thank you for that. Well, probably some of you, most of you already know Saffora, which then means that you won't be surprised when I tell you that the past 10 months or so was a great fun. So I think we learned from each other as well. And I think if the plan still holds now, instead of a busy project agenda, Saffора's agenda will be filled with sun, sea, vacation in general, and I fully endorse that. But when you're back, all I can say is sky is the limit. And to use our code, good luck. So, I hand this over to you. I understand. Congratulations.
Okay, the next two diplomas will be handed out by Professor Frank Village from the TV. He will first address Michail Serekis and afterwards Lazarus de Faridikis.
Good afternoon. Dear Michail, unfortunately your company supervisor could not be here, so Thijs van Keulen from DAF Trucks, he is excused. But it's definitely my pleasure to address you here because I was Michail's university supervisor during the last 9 months. So Michail did his project at DAF Trucks, and besides the safety aspects already addressed in the previous talk, one of the big challenges is efficiency, so fuel economy of these trucks. And over the years that was already important due to operational cost, and that's quite obvious. But for the upcoming years it will dramatically increase because of CO2 reduction challenges that lie ahead, but also on the longer term scarcity of fuels. So fossil fuels, but maybe even in the end sustainable fuels. So having said that, it's really important to come up with a technology that we can maximize the fuel economy of these vehicles. And waste heat recovery is one of these promising technologies that have proven in our own tests to see that we can even improve fuel economy by, let's say, 4 to 8%. And that's significant because if you realize that the amount of fuel we put into the vehicle, so the chemical energy content that is in there, basically we throw away, we waste 55%. 55% of that energy is simply going into the cooling system and into the environment. And that's really a waste. So the question we raised to Michail was, okay, we have this system, we have ideas to further improve that, so even go beyond these 4 to 8%. And please, can you design a predictive control strategy that helps us to benefit from the characteristics we have in that system by using information, so-called preview information that is available about the route, the future route. So we know where we're heading to. And that's already done for safety features, for adaptive cruise control, but basically that information is not used to optimize efficiency. Now, what Michail did in his work was he followed a structured and model-based approach to come up with a solution. And in a simulation study, he proved that there was a significant contribution. And this morning I learned that I'm not allowed to tell how good the contribution is, but the people at DAF, they had smiles and they were very happy. So I think that was a good indication about the value of your work. So that was significant. So you developed a receding horizon control algorithm that uses a model, a wasted recovery model. You validated that model on real data, and you showed that it was possible to use that information from the future to maximize the recovered power. And basically, large part of that work was done in the final stage of your project. So that made it quite challenging and intensive at the end. But you showed your determination, your commitment to get through, and you got your job done. And also with a lot of focus on details, and it needs to meet your level of quality. And I think that was in line what we heard this morning about you, that your colleagues said you are perfectionists. So I think we also have seen that. So I believe you can be very proud with that result. During the project, we also got to know you as a pleasant and well-organized and hardworking person. You also had to address with many other companies, with many other stakeholders, because your work was part of this big European project. And you really managed well to get everybody happy, which is always very important. And I think that also demonstrates that that is one of your talents in this. So before I come to the end, I want to thank Thijs van Keulen, Bram Hakstegen, Jeroen Smits and Johan Vromans from Drafttrucks. They support you extensively doing this work. And also on behalf of them, I want to congratulate you, but also your family who took all the trip from Greece to be here today with this important milestone in your career. And I wish you all the best for the future. Congratulations. Don't miss the slash. Lazarus, can you please come over? Dear Lazarus, we cooperated intensively over the last year, I think even more than that, 14 months, because first we were involved in a group assignment and later during your final project. So as your supervisor, I'm very happy and glad to be here and have the opportunity to address you. For your final assignment, we had a very challenging question to you, because we have an engine in our laboratory here in university. And basically the question to Lazarus was, okay, we have this crazy idea of calculating actuator actions and adapting the fueling profile in the combustion cycle. So not waiting till the next combustion cycle, but do it in the combustion cycle. And practically that means we ask him to develop a system that can respond in 1 millisecond. And in that 1 millisecond, we process data, we calculate control actions, and we apply those control actions, which in this case is a fuel pulse. And to if you imagine that as a reference that our response time of a human is 200 milliseconds, so that would mean it's 200 times faster. But it was even 10 times faster as the system we had at that time in our laboratory. So very challenging project, and you were very happy to start with that. So we are also very happy with that. So why is this an important technology? Because we believe it's important for future clean and efficient combustion concepts we are working on, together with DAF, Shell, and also TNO. And these concepts, they are very sensitive for small changes in operating conditions, so in changes in the air part, in the fuel part, or in the cooling system. And that can even lead to unstable combustion, which means we, in normal practical words, we destroy our engine. So as you can imagine, that's not what we want. So what we want is to, on the fly, adapt the fueling profile, avoid this damage and misfire, and even in the end follow an ideal heat release trajectory which gives us the very best efficiency. Lars investigated first the required control hardware, so you first need hardware to do this. And you did that in a very systematic way. You determined the requirements and you did a lot of telephone calls with suppliers. And that was also your strength, we believe. You kept very persistent in asking them for information, and you kept doing that until all the answers were collected we needed. And this nicely illustrates your skills to deal with these different parties, but also to have a look on the result and the quality of your work. Also during the implementation on the engine, because that was the next step, we purchased the system based on your recommendations. You teamed up with and closely worked together with our technical staff and also our PhD students. And as you showed this morning during the symposium, you finally succeeded in meeting this requirement and really demonstrate that on the engine. And this is a great achievement and not straightforward, as I can say by my own experience. Because typically by implementing something in real world, there are always a lot of setbacks, challenges as some people refer to them. You stayed very determined, you analyzed the problem very systematic, you worked very hard on it, and in the end you solved all these problems and made it work and show that we can do it in 1 millisecond, which was not, we believed was already possible on forehand. So very good job there. And for our research, that is a very crucial and important step forward to do this research on these high efficient concepts. Unfortunately, due to these practical issues I was referring to, there was not sufficient time to also implement the control strategy you proposed, a new control strategy. However, you transferred your knowledge to our PhD students, and we are really keen to test the ideas of Lars in the very near future. So I think also that shows the value of your work. Before I conclude, let me especially thank Theo de Groot, Xi Liu and Robert Willems from our university, but also Frank Engels and Daniel Escobar from TNO, who also support you with a lot of practical questions. So from here, I want to thank you for your valuable contribution, and I wish you all the best for the future. Thank you.
Okay. Next, Sengyu Lee will be addressed by Maldonado, Emilio Maldonado.
I'm tiny, okay. Over the course of the past year, I was really hard on Chang Yu with respects to his documentation efforts. So I knew that it would be generally a disservice to improvise my speech. So I wrote it and I ended up with a first draft that took 15 minutes to read. So I cut it and ended up with 10 minutes, then I cut it to 5, then I cut it to 3, and I didn't like it anymore, so I rewrote it again. I would like to defer to my speech, which I conveniently have on my phone because I don't trust my handwriting. Punch Powertrain is an independent, full system supplier of fuel-efficient powertrains. Over the course of last year, we have seen our research and development office in Eindhoven almost double in size, due in part to our commitment to develop innovative and disruptive technology in the area of automotive powertrains. Our latest endeavor, in which Chang participated, is a hybrid version of our dual clutch transmission solution with an aim to reduce the cost gap many OEMs face with hybridization. As we have seen during today's presentations, gone are the days of just pen and paper automotive design and engineering, as ever more technologically advanced developments are undertaken. Today's engineering efforts necessitate robust simulation procedures in order to ensure their efficiency, safety, and their compliance to customer requirements. Chang Lee's contribution to the present DCT project was the development of a robust simulation environment through which the System Engineering Department of Punch Powertrain could validate architectural design choices, as well as provide feedback to customer requirements related to transmission performance and efficiency, as you can see in the title of his thesis. His work was key during the conceptual phase of the project and allowed us to swiftly and confidently communicate with our customers and pass a critical design tollgate. In mere months, Chang went from an agreeable but somewhat timid individual to an assertive and opinionated team member. From an engineer eager to learn to a systems engineer getting asked for consultation from other departments. From my personal assignee to my colleague. And I don't mean that figuratively either, as he has been hired to continue his work in our office as we move into the detailed design phase of our current product. Thus, I would like to finish by once again congratulating Chang Lee for his effort, thank him for his professionalism and enthusiasm, as well as take this opportunity to welcome him to the Punch Powertrain family. Now, I would like to add as well that over the course of the past year, this development process that we went through had a lot of scope changes, we had a lot of delays, and Chang demonstrated utmost professionalism in being able to change his planning and adjust the scope of his project to be able to meet all of our deadlines, to meet all of our milestones, and just in general, present himself as a really, really good engineer. And I'm very thankful for that. Thank you, Chang.
Thank you. The next candidate is well, I was fortunate to chair also the exam session of, but I still need the paperwork to read your full name. Hassan Mohamed Hassan Mahmoud Mohamed, and he will be addressed by Michail.
Welcome, everybody. Hazem, it's a real pleasure to finally reach this moment. I was your supervisor at university together with John Kessels from DAF. He unfortunately has a project meeting today that you know of. So he asked me also to pass on some of his message. For both of us, it was a real pleasure to work with you. The topic you can see from the title. So it's connected to predicted driver assistance systems, functionalities that lower the fuel consumption. Basic example that such a system is what you do yourself sometimes when you drive and you see that there is space to the next intersection and the traffic light turns red, so there is no point in accelerating and braking at the last minute, but you take your foot off the gas pedal and let the car gently go to a stop, and that saves fuel. So what Hazem did for trucks, he implemented an automated algorithm which detects, based on the radar and the distance to the front moving car, when it is more optimal to release the throttle so that you can save fuel. And he also came up with a warning system that let the driver knows when he can lift off his foot pedal. And in the end, it was a nice idea. We tested it in simulation, we looked at the data, and it proved to be working. And many nice ideas stopped there, but that was not enough for Hazem, so he really wanted to test it on a truck. This is when his great determination and network skill comes into play, because he had to go over quite some obstacles. For example, when he contacted the testing department in DAF, at first there was no truck available, then there was no driver available, then there was no license plate available, then the keys of the truck went missing, then there was no volunteer for driving the preceding vehicle, and finally Hazem managed to get a run with John and the truck driver, and he implemented his system on a real truck, and he got successful results. So we're congratulated for that. His results are also part of the European project, where more truck manufacturers are working together to develop such systems and to integrate them with advanced road infrastructures. As a person, Hazem was a very nice person to work with. He was highly motivated and creative. Every day would come with new ideas. Sometimes he would be so fond of his ideas that I found it difficult to convince them to adopt them. But what I liked about him is that he always gave me arguments and tried to reach a compromise by reasonable means. He was a team player. He networked very well with colleagues both at university and DAF. We always appreciated that you bring sweets and cookies when there was something to celebrate, so we will miss that. And we could also say that you integrated very well in the Dutch culture. One could even say that Hazem became addicted to the Dutch croquette. Apparently, it happened that he ordered multiple days of the week for lunch, 2 or 3 croquetting and nothing else. So finally, Hazem found a new job at an automotive company in Germany, and would like to congratulate you for this. And we hope that your visa procedure will end quickly so you can start your new job. So I would like also on behalf of John Kessels to congratulate. Thank you.
Okay, next, Victor Zoyer will be addressed by Michail Schmierman.
Okay, there we are, Vincent. A few years ago at Blueprint, we started to realize that we had to change from a technology using company to a technology owner. And that's a matter of a change that we are still undergoing, which is still happening. And one of the steps he wanted to make is he wanted to own more knowledge about vision technology, because till today we are fully dependent on a few suppliers which are selling us a kind of vision black boxes, and that's hurting us in all aspects. So we defined a project and we searched for a kind of partner which would help us to go along that road to the promised land of independence. We found it in the TOE, and we found a guide that was Vincent, coming straight from Swiss, so he knows what the guides have to do. He made a detour via Eindhoven, we'll forget about the details. But yeah, being a guide is a very lonely job. You had to work together with Thijs, and well, the two of you had to do the job. There was no knowledge about vision in Woerden at Blueprint. And well, you had really to rely on your network at the university and other partners to learn and to see what we could do. That worked quite well out in the end. Yeah, what did we learn during the project? Quite a lot. For example, it's always important to keep selling your project. That it's not we put an investment in there and then we believe it will happen in a year, but you have to keep selling it, trying to put in the benefits. Also, you had to learn different languages. And different languages, I mean the academic language on the one hand, that's very nice. Yeah, of course, yeah. Maybe you are able to do it depending on certain environmental issues. And on the other hand, the more business-like answer, yeah, of course we can. maybe there are some minor issues we have to resolve, but fine. That was quite a learning trajectory, but you did, and it worked again out quite well. Yeah, and what else? You worked in a very hectic company, because Blueprint, we are running around with all kind of projects we are doing for customers. Even Thijs running away in most critical moments, leaving you alone again. But yeah, you did your job and you did it very well. Thank you a lot. And if I can summarize this short summary of what you did at Blueprint, if you want to guide someone to see to have a bright idea, to see the light, the first thing you have to do is show him where the light switch is. And that's exactly what you did for us, and I have to thank you a lot for that. Good luck.
Rokers van Iping will address Kiyoung Wei.
Thank you. So, Bosch transmission technology in Tilburg. We are active in the automotive field. This field is rapidly changing due to powertrain electrification. This seems to the logical answer to handle the changing CO2 regulations. And this change creates new challenges for our sector, and we now need to combinedly study the mechanical, electrical, and thermal domain in some sort of holistic approach. And until now, the thermal domain has been somewhat on a lower priority. So, to prepare ourselves for this new approach, we need to develop new knowledge, technology, and tools. Therefore, Bosch formulated Kiyoung's assignment, which you can read here. I don't know what Kiyoung was expecting when he started 10 months ago in Tilburg. However, he found a sort of blank canvas. There was no prior research done on this topic in Bosch Tilburg. However, he started with a lot of enthusiasm, and within a very short time, you already presented a very challenging timeline for your project. So I must admit I was a little bit skeptical, and I was expecting many delays, which actually is quite usual. However, somehow, week after week, you managed to keep your schedule. It took perseverance and very long working days from your side. But in the end, you did it. So you started with studying literature, lots of literature. I remember that at a certain point I think you were telling me you were collecting over 400 papers. So this vast amount of information you used to create a basis on which we could build this activity. Then you decided to integrate thermal and energy management, and to study the potential of CO2 reduction. You chose a rather unconventional approach. You tried to develop a new method that was not yet available within Bosch, and even for this specific application, not yet in literature. Yeah. So therefore, you could not really rely on knowledge of your Bosch colleagues. You had to do it by yourself. However, you did find ways to connect to many Bosch colleagues, because you needed some information on the reference system, a base knowledge on transmissions and automotive technology. If you need something, you will fight for it. So in the end, it was no surprise. you achieved the goals, and I think we are onto something here. We can really save energy by looking at the thermal domain. And therefore, Bosch really is planning to go further in this set direction. And I'm very glad that we can do it together with you and with Theo Hofman, with the TU Eindhoven, and extend it into a PhD. I really enjoyed working with you the last 10 months and looking forward to doing this over the coming years. But I think it's very important to now step back, relax a little, and I think celebrate on what you already achieved. So, I think now I can hand you over this diploma and congratulate you for mine and also Will for Rijks.
Okay, the next intermezzo is you should not watch, but this is really the most crucial part. I propose you swap the names and then move back and forth. Okay, you see it worked well. Everyone has found a place again. There are different names, so I'm very happy we have the team complete. Next diploma will be handed out to Andreas Krivas by my neighbor, Ingenieur Brouwhuis, please.
Hello, Andreas. Hello. Family, friends. And I realized today, after hearing all these speeches, that you were in a totally different area. Because we are in the middle of a very exciting digital, but also a very disruptive smart transition, where everything is connected to the internet, and intelligence is not only in your brains, but also on the internet. And we must hurry. That's the reason why we invited you to help us out in understanding what to do in that area. We are, with respect to this smart transition, when you look at our region, somewhere between the level of 1 and 2, on the scale of 10, with respect to smart cities. So there's a potential risk that we will end up as a third virtual world country or a development city. And Andreas, starting humble, very quiet, he felt himself as an entrepreneur in the area. You couldn't escape. And helps out with preparing the next phase of FIBE, with coming up with a FIBE recommendation. Thank you for that. Focusing on smart mobility. FIBE is all about smart mobility. And we have to understand, and he was working on that, to understand the smart challenge we have in the nearby future, in the first place, but also in the second place, what we have to do to be successful in that arena. And I can assure you that it's quite a challenge also for us as a region, as a company, but also as a university. Andreas, thank you very much what you did. With your entrepreneurial behavior, we couldn't escape. We appreciate you very much in what you did. It was really needed, and you helped us to prepare these decisions, tough decisions we had to take to become successful in the smart arena, in this case with respect to smart mobility. So, congratulations with your diploma. As you see, I prepared for a 3 minutes speech, and I really hope that you'll be active in this area, because what you did in the last 3-4 months was really excellent. Okay, thank you very much.
Okay.
Ramesh Ismail will be addressed by Dr. Gerardo Daaldrop.
So Ramesh, there you are. Great to see you here, almost having your diploma in your hands. You have been working on lane centering for automotive, so cars keeping their lane, basically the center of the lane. And you have overcome many challenges and problems. And that in an area which has many more challenges, which is what we are working on in NXP Automotive. We are basically in automotive, the innovation is more and more caused by the electronics in the car, not so much the mechanics, but more and more the electronics innovation is driving the innovation in automotive. And when you think about highly automated driving, that will cause a lot of innovations in society as well. And that's why we are also interested and motivated, and certainly Ramesh is, to work in this area. So you can think about applications as last mile transport, what can be caused or what can be induced by highly automated driving. Basically, your personal mobility getting much better integrated to mass transit mechanisms. New ways to do transport on campuses in the center of towns, etc. Really a lot is going on there. So all these opportunities, all these innovations will lead to huge opportunities. And on the other hand, we also think that highly automated driving can lead to a lot of more safety, because a lot of safety is caused by inattentiveness of humans. However, we as humans have learned to anticipate on behavior in the traffic. So whereas computers are always attentive, can computers really learn the intention and the behavior of everybody or everything which is on the road? That's a big question. So we are dealing with an innovation or a dilemma innovation here. We think it should be doable, but is it doable? And Ramesh has taken one problem in this huge field of automation of vehicles, which is lane centering. And basically in that area of centering the vehicle on the road and keeping the vehicle right in the middle, that already can prevent a lot of accidents. And what Ramesh has done, with the help of really a renowned vision group here at the university, it's a world-renowned group. We had an excellent partner there in the form of Gijs Dubbelman, is combining model-based vision with probabilistic aspects, which are aspects which are more taking place in deep learning. So you are really in the center field of what is interesting nowadays. But basically, what nowadays is happening, it's running on big computers. They take a lot of energy, takes a lot of compute cycles. It also is not extremely fast. And what you had to do is basically make these algorithms suitable to run on low power, cost-effective chips. And you had to go really deep down into the technology to make it work. And that is not easy to do. It takes a lot of perseverance, but you accomplish that. And that was a big chapeau from NXP, but also from the professors Gijs Dubbelman and Pieter de Wit. So very well done there. So you managed to take a deep dive inside the technology, but on the other hand, you had the overview of how this fitted and will fit in a car, because your algorithm is being implemented right now in the self-driving car of TU Eindhoven. So that architectural overview you had as well. So you have been very hard working to accomplish all of this. You think you didn't accomplish enough, maybe, but you did do a hell of a job, really a lot. You have been communicating in a very good manner across the company and to other stakeholders. And in effect, you have not been afraid to take on a very big challenge. And this big challenge is only a small piece of the puzzle that we all have to solve in the area to go towards highly automated driving. So very well, job well done. I think your talent has been recognized because I think you have been having multiple chances to go at work abroad in the Netherlands, here at the TU Eindhoven as well. That is already saying something, so you have high standards of what you can pick. We at NXP have high standards as well. We don't take on so many people in our group, but you have passed all the interviews at our company. So we have high standards, you have high standards, and we are really glad that you have been choosing for NXP. So again, congratulations and thank you. So basically, we're looking forward to a very good cooperation with you. I think the world is open right now in this area. Lots of challenges for you, and we are sure that you will make a lot out of it. So congratulations.
Dr. Houwing will next, from Rijkswaterstaat, will address Tom Zwijgers.
Yeah, thank you. Well, works. Right, dear Tom, see you again. And I think you must be pleased to see me for the last time. Is it not for the fact that you will get your diploma? Is it for the fact that I won't ask any more stupid questions to you? You did a great job for Rijkswaterstaat. We, as owner of 136 locks, wondering how to renovate all those locks. They're all unique. Asset managers are complaining that they're all unique and they have to know each system by heart, and they don't know, so they have to hire the contractors, etc., etc. It's a lot of money and time consuming. And we have a PhD student from the TU Eindhoven working on lock family. So he's looking which locks are look-alike and which locks you can have for some kind of standardization. But we were more interested in which components within a lock you can put forward for standardization. And I think you did a really good job by exploiting not alone what kind of components are there in a lock, but what are the similarities of those components in a lock. And of course you have similarities on functions, on functionality. But then you came up with the brilliant idea that you have similarities on maintenance. And is that brilliant? Well, if Rijkswaterstaat don't know that within its own assets, its own objects, there are similarities on maintenance, yes, I call it brilliant. So it helps us out to rethink about renovation of the locks, where to look at, how to find which component should be standardized, and find out on which criteria we can choose. Either should it be unique because it's a unique situation, or should we standardize because it will help us out to make a more standardized maintenance strategy or a standardized kind of system. You're very profound, you're very, how do you call that, organized person, and if you have a problem you will stick to it and you will get it out. And then I come again each week and asking you, but can you tell me what DSM is? And then you were rolling your eyes and said, yes, I will. And you're very friendly to me to explain it one more time, what DSM is and how it works, and I still don't understand it. I will call you when you're on holiday. Will it help Rijkswaterstaat? yes, it will help Rijkswaterstaat. And I will tell you, memorize the moment that we both were traveling to the end of the world, Goes, by train, having a 2-hour trip by train and discussing a lot of. And when we arrived there, a colleague of mine is in data handling and data analyzing. And she was, I phrase it politically correct, complaining about the management system of Rijkswaterstaat, who does not believe her that if you want to know something about your object or your asset, you have to have all the data that's exposed. But management of Rijkswaterstaat just have it on a higher level, and they don't mind anymore. So she was complaining. She was feeling like a Don Quixote, fighting against the system, and she thought she was mad until you started your story and explaining what you were doing and what your research in, and then I saw a big relief and a sigh and said, "I'm not mad." And it wasn't for the fact that I was in the room, otherwise she has hugged you to death. And thanking for what you did for her. So it's, I think it's a challenge for us as a Rijkswaterstaat to continue your work. You ended by giving us insight in how we should handle our data, to do the DSM, to do the analysis you did in your research, to have a better insight in what kind of management strategy we would have on our 136 logs. I will thank you for your presence, and it was a privilege for me working with you. I understand that you have already choosing 2 jobs, or well, I think you will get that. I wish you all the luck and have fun on your holiday next 2 weeks, and congratulations on your.
Dr. Witters from Flanders Drive will address Cyrano Vasseur. Cyrano?
Cyrano, congratulations. People who know you will know that you are a happy person, almost always smiling. And so at the start of your PhD, we were also charmed by your gentle, warm attitude. And perhaps this is typical for Suriname, don't know, but at least we were happy to have you. However, some colleagues were wondering, well, isn't he a little bit too relaxed to take up this complex challenge of developing a new control strategy? I replied to him, we will see, but I'm confident that he is sufficiently ambitious and eager to learn, and he will manage to do so. So Cyrano started his PhD and started working in his own characteristic way. You wouldn't say, but he's meticulous. At the start, he identified me as a risk of his project. At first, I was a little bit shocked, but then I realized he's smart. He judged the situation very well. So he was right in it. I would have limited time to support you. But he found a way to mitigate the risk and addressed his questions to my colleagues who helped him forward in his journey in this traineeship. Cyrano's traineeship was a journey of challenges, much more challenges than just dealing with me. He had to understand the functioning of a weaving machine, which is quite complex. He had to develop a new control strategy, and he had also to prove that this control strategy would work in practice. And believe me, from my own experience, developing a theory is one thing, but putting it into practice, it never works from the first time. Those who attended the presentation of Cyrano this morning will have learned that he managed very well. He developed a strategy and put it into practice, and build the first key component to make weaving machines more productive, more performant, more reliable. So Cyrano, thank you a lot for that. And yeah, we wish you all the best in the future, and we are happy to continue cooperating with you. Congratulations.
Ingenieur van de Boogaard wil address Nestor en dan that's Rodriguez.
Hi, Nestor. In your time at Thermo Fisher Scientific, still FEI when you started, we've seen you develop both as a person and professional, as being a real skilled engineer. At the beginning of the project, you searched a bit to find your role and the direction, but actually you managed to get really quick up to speed. And after that, you've worked with dedication to reach our and also your own goals. I remember quite a number of occasions when I came into the motion lab or walked into you on the hallway, and I could just see by the look in your eyes you were proud that you achieved good results. And I think proud you can be, because eventually you've reached all the goals we set, actually. Unfortunately, we cannot disclose too much in detail on the work you did, but I can say that the work you did is valuable information for us for our future product development. Yeah, the biggest sign of recognition, I think, is the fact that Thermo Fisher offered you a job, and I'm happy that you accepted it. So as per tomorrow, we will be colleagues. And I'm looking forward to work together with you to continue the journey we started 10 months ago and put it into a successful product. And I would like to congratulate you again with your...
Last but not least, Arash Romi Sadeh will be addressed by Dr. Edo Aneke.
Okay, good afternoon. Hello, Arash. Here we are. After 1 year of hard work, we are now here to finalize your work. Maybe a short introduction. My name is not Ralph Nooyen. I'm not sure, yeah. Basically, Ralph is a member of my team. Unfortunately, he's now preparing for a trip to Taiwan to visit one of our customers. So he had no time to join, so I'm his replacement for today. Yeah, let me just have a short introduction. Arash, when I joined the ALSI, you were already working within the system engineering department. So in the team of system engineers, 14 software engineers on the 3rd floor. And basically, when I started at ALSI, I was very interested in your work, because when I entered the ALSI, I saw a system. The first question I got for myself was, how much performance is still in the system? Because as you also know, we're always challenged by our customers to deliver higher accuracy, higher speed, and this all within the same boundaries on reliability. System should always be cheaper. So your work was quite important. So basically, when you started your work, you did a lot. You started modeling the system. You started discussing with the software team what could be improved in the controls. You went to VDL-ETG, our supplier. You talked to CCM. And in the end, you basically laid out the foundation for future developments within ALSI. Because, yeah, you were highly creative. You've basically defined a number of methods we can use to improve the performance. But not only did you investigate these different methods, you also showed them on the system, which I think was quite a challenge, because I know how much time it takes to develop the system. Yeah, and still, until today, I still got complaints from our system, because people always complain within ALSI that software development takes so long. So then when Arash wanted to test his method on our system, he needed software support. So you went to the software team, and yeah, to my surprise, within 2 weeks, you had a working piece of software. Not only was it developed by some software engineers, but even the team lead software engineering was modifying the software for you. So I was really amazed. Great job. Yeah, looking at your time within ALSI, I fully support that you're highly creative. You worked extremely hard. Also, in the end, you had to scramble to get your report finished on time. So I think that's a learning point. And what I also really enjoyed was you could work with people very easily. Also, this is basically, I think, one of the reasons why you were able to get your software so fast. Well, the complete company was always complaining that software would take too long. And we're very happy with the work you did. So also within our team, we now have people who are going to pick up your work and develop it further. So you have investigated a number of methods. One of the methods we're now investigating is the collaboration with MI Partners. So a high-tech company here in the region of Eindhoven. And together with them, we're now developing new dampers for our system, which will allow us to even increase the performance further. So great results. I want to congratulate you with the work you did. Also, congratulations to your family. Yeah, you deserve a vacation. So now it's time to relax. And I would like to congratulate you with your work.
Okay, it has been a long session. We should finish in 1 hour. But because of the change, it was 5 minutes. You will forgive us that. Congratulations, all young professional doctorates. And also not only you, but all your family and friends. I know that for some of you that has been hard, people, family far away, and in that sense it's a great thing to have this event today. Before going to all the festivities and congratulations and drinks and whatsoever, there's one serious part left, and I want to read out that loud, and I think it will be clear. The scientific degree of PDeng involves duties as well as rights. As a holder of this degree, you are committed to standards of scientific integrity, trustworthiness, intellectual honesty, openness, and independence. These standards are described in more detail in the Netherlands Code of Conduct for Scientific Practice and in the Eindhoven Code derived from this. You also have duties towards society. You must be clear about the boundaries of your own expertise, and you must communicate honestly and independently about the results of your work, including potential risks associated with it. You are committed to ethical codes for research and design involving human subjects or animals. Take that serious as a final lesson of me. We come to an end. You probably have not noticed, but this is also for me is a special event. I became director of the PDeng education since April, and it's just fun to have such an event. I mean, all the work involved in that, I leave that mostly to Peter Heuberger and Ellen van Hoven, secretary. And I'm very happy just to stand here and shake hands with you and have a drink with you. That's the role of a director. I enjoy that, and I hope you share that feeling with me. As said, I'm closing the ceremony in a very particular way. You, as a public, you stay here. Okay, I don't know anymore. After 4 times, I mean, as I said, this is the first time for me also. Yes, what do you want? Okay. I propose that you as public go out first, and we stay here, you guys and we guys, and we will join you later at the drinks. Thank you for all being here.